Hello world, this is Chris with Elevations doing an overview on the Stinson1 quadcopter. I'm going to start with the power system here in the rear, since it seems to just make sense to start where everything comes from. So down here in the bottom is the two different battery bays. They are wired together in parallel to give us a little bit more milliamps for our flight. You can see on the very bottom here, see if we can get some more light, that there is the Raspberry Pi or the initial computer UPS in there. So that particular one outputs here on these three USB ports. Fix that focus. These three USB ports right here output standard 5 volts. And even if we do lose power or we need to do a battery swap, the computers will stay online because of this device right here. You can see on the right hand side there's that little blue button. And that blue button is the button used to turn it on and turn it off. So a single click will turn that on, and then a long click will turn that off. We have our power module right here, zip tied at the bottom of this little plate. And if we come up here, and this is where the Raspberry Pi, the 4G hat, as well as the LoRa hat lives, so it's inside the core of the drone itself. On the right hand side we have the receiver, so this is the radio receiver for your ground station transmitter. Then we have the Pixhawk 6S, and we have the 4 connections for the battery, so that goes the 4 connections for the ESC, so that goes out to the ESCs to actually control the individual props. And then here in channel 7 and 8 we have PWM3 and PWM4 controls, and that is going to be for the FLIR VUE Pro RAD camera, that thermal camera. So this is what gives us the ability to zoom as well as change our white hot versus what color we're going to want. Over here on the left hand side is our video transmission module. So this particular one inputs, you can see on that yellow line, that's actually the video input. Then we have power input right here. You have the ability to change a channel if you would like, but we typically just stay on channel 1. And this is all operating on 5.8 gigahertz. Here on the top, this is the GPS module for the Pixhawk 6X. And then we have the LiDAR system. So this is a 360 LiDAR. So this is what gives us a little bit of obstacle avoidance. Down here on the left hand side of the Pixhawk 6X, we have the video system. So here, this is a simple AV input line, and this is actually what's giving me input to the Raspberry Pi for view over the computer, and that's what this USB port, that's what this USB cable is going down here to the USB port on the Raspberry Pi. And then I decided to keep the standard AV type of line coming off the FLIR, so I didn't want to cut this line. That is a specialty cable, so we just kept that cable there. Since we're on video, we'll rotate left and look at the left hand side of the drone. First thing, so coming back to where we were with the video portion, this is a USB tuner, so that's plugged directly into the Raspberry Pi via USB, and that allows us to do import of whatever video channel we're utilizing, so we can see that over the Raspberry Pi. Then we have a 3-channel video switcher, and that's actually controlled over PWM. We're using channel 1 and channel 3, so we have a simple toggle switch to flip that back and forth. And then we have the antenna for the 4G connection for that 4G hat on the Raspberry Pi. This is back where that video transmitter is. And then here we have the RFD900X. This is the telemetry radio. It's actually been a really good quality radio. You can notice that I do have that upside down. Keep a note, these are omnidirectional. Granted, it would be ideal if I had it mounted in a more normal fashion, but since they are omnidirectional, it means the weakest signal is downward or straight upward, or if it were looking at the radio, this would be down, that would be up. So in reality, since these are omni, our strongest signal is going forward and backward and left and right in relation to the drone. So in reality, as long as these are straight up and down, either upside down or right side up, we still do have really good signal quality. And even if we are 5+ miles away, I don't think I've seen under 80% signal quality. Now, if we look here inside this section, this is the power for the USB to 4G hat. That's power and the uplink for the actual data. And this is my USB-C cable that feeds from that Raspberry Pi UPS to my power plug here on the Raspberry Pi itself. You see everything's kind of just tucked in and routed through there. Now let's scroll down a touch. So here we have a siren. That's a 24-volt siren. So if we do activate that, that helps to move some of the livestock around, which is a loud, annoying sound that they definitely try to get away from. Then we have the ESC power feeds, so you can notice they all come from up top. That's predominantly the power source. I do have a power distribution board up underneath there on top of the stack that's on top of the Raspberry Pi UPS. Now coming back up, we're back here to the LiDAR. I want to take note here, since this is up and injecting in the way of the LiDAR view. Since we do have the 4G, I do have that thinner, and we also have these kind of bulks, so that rear left is where we lose a little bit of our obstacle avoidance, but my predominant goal was to make sure we didn't run into anything as we fly forward, since that's the predominant motion we're going to be doing. This is a simple ability to turn that siren on and off just by simply plugging that in or unplugging it. Now this system overall on the drone, I do have 3 separate power systems. We have a couple different buck converters to drop everything down. So with our 6S LiPo batteries that we put in that battery bank, we do drop that down here, with this being a USB buck converter. So we drop down to 5 volts, so I do have USB output for 5 volts. And then as we swap this around, we can see we do have another converter. Now this one's adjustable, so I do 24 volt input, and then I have a 12 volt output, so that helps with some of the 12 volt systems that I have on board. Let's come down here and take a look. We do not have a separate gimbal mounted here yet for the FLIR camera, but we have 2 camera mounts out front with this custom 3D printed system, a little reinforcement with a small piece of aluminum. So this is the, I do believe that's an A8 SIYI camera, the A8. And then we have that FLIR VUE Pro R, and this is the 640 resolution version, as well as that 30 refresh rate and 13mm lens, so that gives you a pretty good view on everything you're looking at, as well as good resolution even if you're at about 150 foot above the ground level. Looking here at the front some more, so as you can see, we do have, coming out of that power distribution box, I do have a couple splitters here, and this system was designed specifically just for auxiliary power. So all the extra 24 volt, it is not going to the ESC, comes right out of the front and then splits that out to whatever other power systems that I have. Since a lot of the weight of the batteries themselves are more rear facing, a lot of the power switching system is out here in this front panel. So again, this is the converter to bring everything from 24 volt down to 5. And then here is our buck converter to go from 24 volt down to 12. And then obviously we have our Pixhawk up top. And I've been jamming some stuff in there, so the alignment is not perfect. Now if you see right here, up underneath this arch that we made, that is a small TFT screen on the rear facing for that mount. Allows me to do a little bit of output, so I can give a readout from the Raspberry Pi itself to the user. Now on that rear left, you can see that is a temperature and pressure monitor, so that gives us information about the current operating temperature as well as pressure, so that gives me altitude readings. Swapping around here, again, now at the bottom, we're at that FLIR VUE R640. So here are the PWM control lines, as well as that USB custom cable that they have. It's a little bit proprietary for that 10-pin connection. Coming back up, we can see the C lines. Now this is one of my USB feeds that goes here to the rear, and this is what we have just from some rudimentary cable routing. So that's where we actually get power for the FLIR. We can plug that into the Raspberry Pi directly and have access to those files as well. Now the side right here, we simply have the 900 megahertz LoRa antenna, so that Raspberry Pi can collect data from some sensors that we've put out. And then we have that receiver and LiDAR 360 here on the top. Again, something to keep in mind here is that is the button right there, that little blue button right there to turn the UPS on. And we can see on the front, it's not on right now, but you'll see a couple different blue LEDs that'll be glowing when that is on to indicate battery level as well as that on-off state. Now we do have these nice T motors right here, as well as that 3D printed mounting system and these very large carbon fiber blades that have certainly been performing very well. Even tapped the ground a couple times without any big issues. So that's pretty much everything that we have right here. Again, here on the rear, we have all the USB and the Ethernet facing directly to the rear to make that nice and easy. As you can see, let's get a better focus and zoom in. Because of time, because of space, we actually custom mounted a lot of these hats. And as opposed to the normal jumper you're gonna have, we actually have a soldered jumper on there. So there's room for the LoRa hat on top with a good connection. So that makes things a little bit more unique, a little bit more custom. Obviously we do have 5 volt coming right off the back of the Raspberry Pi with that USB connections, and that's something where we could take that FLIR camera and plug it directly into here, and then over the Raspberry Pi we have access to those files as well. That is everything with the Stinson1 the way it sits right now. There's obviously still some more cleanup and some more modifications to do, but that's what we had. My name is Chris with Elevations. As always, I hope you learned something today. Please like and subscribe below. Thank you for watching.